Today I'm going to show the final implementation of our advanced graphics programming project. In this project we have attempted to implement several features that I will show through the course of the video. In this first room, on the bottom left and centre, we have what we call the combination shader. The first part of the shader is normal mapping. This is done using a normal map texture that is used in calculation with a tangent by tangent and normal matrix to adjust the normal of a fragment. This shader also has the effects of light mapping and can be seen best in the center block. On the right, we have a shader that only takes into account light mapping and multiple lights. Light mapping is done by taking the RGB component of a light mapping texture, and this is applied to the diffuse, specular and shyness components of the shader. Also, this shader has a function that allows for the effect of local lights to be turned on and off. Multiple lights are also implemented on the blocks using the combination shader. Light is summed in the shader, though the effect is a little weak in the scene due to no contrast from the shadows. As you can see, the spotlight no longer has an effect on the blocks in the top once they have passed it, but the point light continues to affect the blocks all the way through. This is more obvious on the top boxes, which are only using the fog shader. All levels have collision detection implemented. This is to stop the player from being able to pass through walls and also pass through doors, though based on the implementation it is possible for them to pass through if they press both the forward or backwards and left or right buttons at the same time. The collision detection is also implemented on the collectibles within the level. When you collide with the collectible, it stops drawing and will also open the doors. This would also lead on to multiple rooms. The second room is large, as we intended to have shadow mapping here, and we thought a large room with multiple lights would have shown the effect well through shadow blending. But at this stage, the program only has a partial implementation. This would have worked by rendering the whole scene once to a frame buffer object, and then using that frame buffer object in the second pass to apply shadows. We use the particle emitter to create a fire effect. This would also have been used for the location of the light sources in this shadow mapped room. These work by creating a point sprite using a vertex array object with two vertex buffer objects containing the positions and colours of the particles. The level ends with a congratulations message when all the keycards are collected, as you can see in the top left. Though in a full implementation of the game, each room would have had its own keycard with a door that would have led on to new rooms. Thank you for watching.